Parallelogram of forces is used to find out the resultant of two non-collinear and concurrent forces. Suppose this is my first force, P is the P force vector, and another one is your Q force vector. These are non-collinear, not in one line, and both are at an angle theta to each other. And concurrent means both force passes through a common point. Concurrent means if the force passes through a common point, then these are the concurrent forces. So here these two forces are coplanar. Coplanar means forces are acting in the same plane. So in this case, P and Q force are coplanar and concurrent force. Concurrent means these two forces pass from a common point like this. So the magnitude of these two forces you can find out using the parallelogram law. So if two forces acting on a body, then the magnitude and direction of these two forces can be represented by the adjacent side of the parallelogram like this. This is my P force. Another force is my Q force. The Q force component you may shift this force here from here to here. So this is my Q force. Similarly, this force you may represent like this. So, and this force vector you may represent here. So in this way you may complete the parallelogram. So resultant of these two force which passes from the suppose this is my Q force which passes through the intersection of these two force. So this is the resultant force vector. So diagonal of the parallelogram represents the magnitude of these two force vector. Now suppose this is the angle between two force theta, and here is you may represent like this is the angle between two force P force and Q force, or you may represent this angle, this is my theta angle. So this one is my 180 minus theta. Suppose this is the angle of the resultant force. If the force act at an angle, so this force having two component, one is your horizontal force component, another one is your vertical force component like this. So this one is my horizontal component of this force is your Q cos theta, and vertical component of this Q force is your Q sin theta. Now this is my right angle triangle. Now in this right angle triangle you may apply the Pythagoras theorem to find out the resultant force, magnitude and directions also. So now this is, suppose this is my O and this is my A and V. In OAB, triangle OAB, the OAB is your right angle triangle. So in the right angle triangle you may apply the Pythagoras theorem. According to the Pythagoras theorem, OB square is equal to OA square plus AB square. The OB square means vector R ka whole square plus OA means vector P plus Q cos theta whole square plus AB square means Q sin theta ka whole square. So R square is equal to P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. So R square is equal to, this is my P square, the combination of these two you will get the Q square, and here inside is cos square theta plus sin square theta plus 2PQ cos theta. The resultant of these two force is R square is equal to P square plus Q square plus 2PQ cos theta, or R is equal to under root of P square plus Q square plus 2PQ cos theta. This is the resultant of these two forces. If the two non-collinear concurrent force act on the object or body, then directly you may apply the parallelogram law to find out the resultant of these two forces. So directly you may write this formula to find out the resultant of two forces. If two forces are non-collinear and concurrent and both are acting at an angle theta on the object. So this formula you may use directly. R is equal to under root of P square plus Q square plus 2PQ cos theta. theta is the angle between these two force vector. Now the angle alpha means the direction of the resultant force. Now this is my right angle triangle. Again you may apply tan alpha is equal to perpendicular upon base q sine theta over p plus q cos theta. So tan alpha is your direction of the resultant force. So in this way you may calculate the resultant of these two forces. These two forces are the non-collinear and concurrent forces. So in this case these are the coplanar concurrent forces and non-collinear and acting at an angle theta. So this the law of parallelogram force you may use to find out the resultant as well as the direction of the resultant force. Similarly you may use also the triangle law. In triangle law of force, you may represent triangle law of force. Similarly, same triangle law of force says. Similarly, if two forces non-collinear and concurrent force act on an object or body at an angle, these two forces have a theta angle between them, then you may represent these two forces by a triangle like this. This is my head, this is the head, and this is the tail of first vector. So suppose first force vector P and second force vector Q. This is the head and this is the tail. So you may represent the side of the triangle like this. The first force vector, this is my tail and the head. Now join the second force vector tail with head of first force vector, and the direction and magnitude of the force, it will remain same. So at an angle theta you may represent like this: second force, the head of second force vector. So the first force vector is your P and second force vector is Q, and this is my resultant of these two force vector. You may represent like this. So this triangle, with the help of this triangle, you may calculate the resultant using the cosine rule. This is theta. So this one is your 180 minus theta. So in this triangle you may use the cosine rule, or you may represent also like this. Suppose this is my, you may consider this is my first vector like this. Suppose this is my Q is first vector, and second vector you may shift here like this. This is a P vector, and the resultant you may represent like this. Similarly, so this angle is your this is the angle. This angle is your theta. The angle, this is my theta angle. So here this is the theta. So to find out the resultant you may apply the cosine rule. According to the cosine rule, cosine rule or sine rule you may apply here. So cosine rule means cos 180 minus theta is equal to P square plus Q square minus R square over 2 times of P Q. So in this way you may calculate the resultant, or you may apply the sine rule also. According to the sine rule, suppose this is my alpha and this is my beta. So directly you may apply the sine rule also if you know the angle alpha and beta with theta angle. Then R vector over sine 180 minus theta is equal to Q over sine alpha and P over sine beta. So in this way you may calculate the resultant of two non-collinear and concurrent forces. So in this case these two forces are the coplanar. Coplanar means the forces are acting in the same plane, and concurrent means to these two forces passing through a common point. This is the common point O point. So these two forces passing through the common point means this is the concurrent. All P and Q are the concurrent forces. The resultant of non-collinear and concurrent forces you may find out using the parallelogram law of forces or triangle law. So this is very simple. In this you will use the geometry, coordinate geometry, or you in parallelogram you will convert with the help of right angle triangle. You may apply directly the Pythagoras theorem, and you can calculate the resultant force as well as the direction of the resultant force. In triangular you may apply the cosine as well as the sine rule. Stop.